Alright, ladies and gentlemen, so in the last video, I used yellow light that was direct. See, in camera work, we learn a lot of things. In this video, I'm using white light, but let me spin that white light around. That's blinding. This is a super bright LED. But as soon as I turn it on to the right angle, that it's pointed exactly opposite me and lighting the back of the wall, and I have a small light source, it works perfect on the other side. And now I have enough light, and if I bring it around just right, and I have this light mounted on a tripod right there, okay? And another light mounted there to achieve the proper lighting. If you guys out there wanted to know how to light your YouTube videos, this is a great way to go. In this case, I'm inducing a light experiment again for this video, but as I've shown, I can get rid of that quite easily. But I'm not going to, because in this video, we are again talking about light. Now, in the previous videos, we've talked about a bunch of things. And in this video, I want to explain in detail how it is that the sun could be actually speeding up objects that are coming in. And in fact, it will be. For sure, guaranteed. Now, here's why. First, we need to know some basic stuff about electricity. This is a solar robot. And this particular solar robot kit is kind of cool. 14 in 1. Because it comes with instructions and a whole bunch of designs. It's a solar robot. Now, the very fact that we can generate a solar panel that works on light is pretty cool. And how that works is one thing. But then there's how electricity works. Now, electricity is both positive and negative. The reason is it has like horsepower and torque. The amperage is the torque. The positive, the horsepower. Now, photons are charged particles. Now, not all artificial light represents charged particles. So let's talk for a minute about what a charged particle is. This cup is comprised of particles. I'm comprised of particles. You are, everything is. But you and I are charged. We are comprised of charged particles. Charged particles are pretty amazing. Living things have a charge and are comprised of charged particles. The sun is comprised of charged particles. And it's spitting out charged particles. We have learned with artificial light to create charged particles that can power a solar panel. And the fact that we do means we can generate artificial light that will charge electrically an object. Think about it. If an object coming from the deep solar system that's been traveling on its own for billions of years or millions of years, it will not have a charge on it. Any charge it had would have dissipated over time. But consider our sun spitting out this huge radiant ball, way bigger than the sun, as far as the light from it can reach, which is way farther than our solar system. It is possible that an object traveling towards that light, by virtue of the fact that light beams get stronger as you approach it, just like when you turn on a flashlight, the closer we get, much like this. Here is a light source. It's pretty dim. It's right there, and it's not even bright enough to illuminate the camera. But as we get closer together, not only is it bright enough, but suddenly it's blinding. And that is the essence of how it works. So consider then that there's this huge sphere of light. Now, part of that isn't, you're not going to get much of a charge. The residual charge has been lost from those particles. The sun, imagine this. Photons carry a residual base charge all the time. But when they come from the sun, we can prove that they are energized beyond that level. They carry more energy and can carry quite a bit. Now, those are highly energized photons. We could call them superphotons. And they, only we don't, they're just charged. But in electricity, we talked about the torque and the horsepower. Amperage is the more powerful force. It's the current. It's the rah. Horsepower, electricity does that through a circuit. It's a push-pull of the actual electrons that are in that are actually moving. And what happens is the current moves because we have a positive and negative, and that flow has to go both ways. So the positive actually comes this way, the negative pushes through. And it's kind of like that. And because it is, and that motion is there, and there's a transfer of electricity through molecules, it's kind of neat. It's fascinating. In fact, it's why I grew up studying it. And what I will say to you is that when you get your lighting just right, as a YouTuber, you learn early on that lighting matters. And if you get it just right, well, your nose looks real big, but that's okay. And if you get it just right, you look well lit, everything looks proportionate, you don't get a lot of shadows. But for that, you need to be lit on both sides. Now, that's a whole nother thing. When objects come in, they're getting lit, but they're not always getting lit equally on both sides. As I've shown, we are getting beams of light traveling within that. But I also propose to you that there are bands separated by charge, and that a negative charge will travel farther through the universe than a positive charge. Negative is traditionally the stronger charge. So let's assume that that's the case. These positive and negatively charged particles are emanating out from our sun in a big ball because the negative particles are likely to travel farther or hold on to their charge is what it is. The ones that are charged negatively are just going to hold on to their charge a little longer because they have the amperage, and the positively charged ones have the horsepower and they don't hold out as much. That'll wear out faster, more than likely. And so when that hits an object, that negative charge is there. It's the only thing hitting it. And as it does, it's charging it with a slight negative charge. But the solar system has a predominantly positive charge because we have a lot of positive light coming from our sun with the negative. It's all bipolar. All our planets are bipolar. That's what makes the whole thing work. Well, there's a reason for that. And I propose to you that the reason is light, that those charged particles are the very reason we have a magnetosphere in this first place. And so, as these objects come towards it, they get magnetically charged, just like the planets are. And the next thing you know, they start racing into the solar system, going faster and faster and faster because the charge increases the closer they get. The beam gets more intense, the light gets brighter, and the next thing you know, they're ripping into it like they're being sucked in by a giant electromagnet. That is really what's happening, because that negative charge, it could be the other way around, technically speaking, in the universe. It could be that positive charges just hold better in space, who knows? But technically, I mean, it could go either way, but it's really irrelevant. The simple fact is one charge is likely to hold out longer than the other because they're very different. They happen at very different amplitudes. And one you could look at as a higher pitch and one as a lower pitch. Well, they'll travel differently in space, more than likely. But photons travel pretty equally, and we know that. So the charge could travel pretty equally, but it makes sense that the excess charge is what we are seeing when we use a solar panel and we take energy off the bounce. Now, that's the other thing. In this video, we're going to take a good look at an actual solar panel, and I'll show you how simple of a device they really are. Because in one of these robot kits, you don't really get a whole heck of a lot, but you do get a lot of pieces, a lot of bits. And it's quite a bit. I mean, you get wheels, you get frames, you get all kinds of cool stuff. And then you get the magic bits. The solar panel. Because it is really magic. And so there's a whole bunch of things that go on when we talk about the universe. Not only are we talking about charged particles hitting this inert object as it comes in, that negative charge affecting it sucks it forward because the solar system has got a lot of positive. And that little tiny negative charge is just enough to start sucking it forward. And the more it does, it just exponentially increases until it reaches maximum velocity. And it's only headed one place, for our sun, because it's the biggest positive and negative pull that we have in the solar system, both. And so they're ripping in towards it. And at this point, they'll kind of just go with the flow of electrons. That's what they do. And that's what I think we're seeing here, is that it's the flow. And it also explains why we have lightning. the atmosphere is getting hit by charged particles. It's not rocket science. We have huge amounts of charge in our atmosphere, guys. So much we've talked for years about tapping it and powering the world from it because it's a huge pool of energy and it's being recharged all the time. It's being charged, freshened, if you will, by particles from the sun. Pretty amazing stuff, right? And so right now you can see across your screen light traveling, just to remind you that this is all about light and charged particles. And we can prove that these are, in fact, charged particles because this is a solar panel. And if you look on the back, you'll notice that there is no circuitry, guys. There's nothing. In fact, there's just a simple band of nickel or zinc or whatever that is. Do you know? It's a composite, but it is conductive. And that conductive material runs through the back of it and connects 2 points. And if you look very closely, you can see the connections here. You've got solder on this side and you've got the panel. And then when you go to the other side, you can see where there's a little filaments inside. And those take the residual charge we're talking about from a photon. Now, there are lots of different types of light, but the 2 types of light I have here aren't enough to power this. Some types of light will power a solar panel right now, and some types will not. This isn't something I feel I need to demonstrate you in this video. I just wanted to show you how simple these really are. There's no extra stuff going on here, except for the fact that there is some power amplification that goes on in the metallurgy. Check load-bearing solder, guys. Same kind of thing, where it has a slight bit of silver and other things, and it adds a little bit of boost to the electricity as it passes through. So we are amping this up a little bit. But the photons are the source of the charge, and they are leaving a residual charge on the face of this as they bounce off. Not every particle will do that. We start throwing small particles of various things off this, nothing but charged particles will make this work because it's the electrical charge that we're getting from it. Now, there are lots of particles that are not charged. So let's say we have this uncharged particle mass coming towards us. Now, at the base level, everything is charged particles anyway. Everything is held together by their charge. That is, the molecular bond between objects is based on their charge and can be increased by charge and removed by charge. We know that. And so, this is held together for a reason. It has a bond, it has cohesion, but it doesn't actually have an energetic charge. These are not charged particles that it's made of, but they are particles. They are particles of matter. Standard matter is not a charged particle. It's the best to look at it that way. So think of the things you see in general in nature as non-charged particles. But then we have living things. Trees are comprised of charged particles. They have a charge. We are. All living things are comprised of charged particles. Water is comprised of charged particles. Light is comprised of charged particles. You're starting to see a theme here. All the really cool stuff in the universe is charged particles. I don't know if you're noticing that, but that is definitely a theme, guys. I don't want to harp on it too much, but it seems to me that the universe is operated more by charged particles and by light and electromagnetism than we're giving credit. And that when Avi Loeb calculates that this object is suddenly speeding up and he don't know why, I suggest you, sir, that this is why. Keith out.